Welcome to solverfy.
Problem we have the system of a telephoto lens, and we want to know first for a distant object located at a distance d0 from the first lens, we want to show that the first lens form an image with the magnification given there, and show that the total magnification is another expression. So let's try to find the relation of the magnification. So we use the equation to calculate the image distance and then use the object and image distance to calculate the magnification. We then do the approximation that the object distance is much larger than the focal length. So let's do this. This is 1 over d0 plus 1 over di is equal to 1 over f1. So di is f1 d0 divided by d0 minus f1. And now we use this in the magnification. M1 is minus di over d0. This is minus 1 over d0. F1 d0, d0 minus f1. This is minus f1 over d0 minus f1. Now doing the approximation that the object distance is much larger than the focal length, this gives us minus f1 over d0. This real image located near the focal distance from lens 1 becomes the object for the second lens. We subtract the focal length from the separation distance to determine the object distance from the second lens. So we can calculate the second image distance and calculate the second image magnification and multiply the two to find the total magnification. So let's do the for the second one. So this is di2 is f2 d02 divided by d02 minus f2. Again, we use this in the magnification too. This is minus di2 divided by d02. And again, this gives us minus f2 divided by d02 minus f2. But now the values are different, so this is minus a half of f1 divided by 3/2 of f1 minus f1 minus a half of f1. This gives us a magnification of 2. This is second magnification. The total magnification is the product of 2, so m total is m1, m2, and this is minus 2 f1 over d0 as expected. Now for part B, for an object located at infinity, show that the lens system form an image that is a distance of 5/4 of f1 behind the first lens. If the object is at infinity from the first lens, we will form a focal length behind that lens. Subtracting this distance from the separation distance gives us the object distance for the second lens. And then we can just calculate the image distance for the second lens, and adding this to the distance to the separation, we find the image distance for the first lens. So di2 is f2 d02 divided by d02 minus f2, and this is minus a half of f1, 3/4 of f1 minus f1 divided by 3/4 of f1 minus f1 plus a half of f1, and this gives us f1 over 2, and the distance d is l plus di2. This is 3/4 of f1 plus 1/4, 1/2 of f1. This gives us 5/4 of f1 as expected. Now for part C, a single 250 millimeter focal length will have to be mounted about 250 millimeters from a camera film to produce an image from a distance d, and we want to know what value, how far in front of the film should the first lens be placed, and how much smaller is the focal length of this lens compared to a 250 millimeter focal length. We set the magnification equal to the total magnification found in part A, and so for the focal length, now we have fm is minus 2f1 divided by d0. f1 is 250 millimeters divided by 2. This is 125 millimeters. Now we use the result for part B to determine the distance of the lens to the film. We subtract this distance from 250 millimeters to determine how much closer the lens can be to the film. So we got that D is 54 of f1. This is 156 millimeters, and delta D is 250 minus 156. This is 94 millimeters.